Okay, here's some help on vectors. First thing to remember, there's 3 parts to every vector. There's the horizontal component and the vertical component. And as they are horizontal and vertical, they're always at 90 degrees to each other, always at right angle. And there's always a resultant vector as well to the components. So have a look at this picture here. You've got your vertical, you've got your horizontal, and that's made up by a resultant vector. Okay, so from here to here to here again can just simply be this straight line, making your resultant component. Likewise, you might have, for example, a force here being this box being pulled in this direction with a force going this way. That too can be broken down into its horizontal and its vertical components. But every time you'll end up with a nice right-angled triangle. And that's because we always use a horizontal and a vertical. That makes the maths a lot easier. We can use trigonometry and we can find the angle. We can use Pythagoras if we wish to find the hypotenuse. Okay. Now for a projectile motion question, we're going to have to apply what we know about vectors and what we know about the Suvat equations in order to predict what's going to happen next. As long as we know the start conditions, we can find out what's going to happen in the future. So with projectile motion questions, unless stated otherwise, we always assume there's no horizontal acceleration and that vertical acceleration is constant. So if there's no horizontal acceleration, then we do not use Suvats. Okay, Suvat is only ever used for acceleration. Okay, and when we're using Suvat, vertical, we only use Suvats for the vertical motion in a projectile motion question. S is your vertical displacement, so it's usually the height or the maximum height that the object will reach. U is your initial velocity up, or it could be down, up initially, down if it's the second half of your projectile motion question, which we'll get to later. And V is your final velocity, up or down again. Acceleration is always going to be gravity, and we've already said constant vertical acceleration. So we're assuming that gravity is the same, even going up and down. So going up, we say minus 9.81 because it's going to be slowing us down. Coming back down again, our object is going to be accelerating at plus 9.81 meters per second. T is the total time in the air. Just be careful when you do a projectile motion question. It's easiest if you work out 1/2 because you know at the top V is going to equal 0, and then you can work out the second half. In this case, at the top, U equals 0, and V we won't know. Okay, here U we won't know, but we'll usually work out